Module 7, Objective 2, explain why receptors respond to specific stimuli and how that information is interpreted. When we look at all the various types of receptors within our body, we can divide them into two main classes. We have the general senses. This describes sensitivity to temperature, pain, touch, pressure, vibration, and proprioception. And then we have the special senses that cover things like smell and taste, our sight, balance, and hearing. Special sensory receptors provide sensations of special senses, and these are all localized in sense organs, such as the eye and the ear, and they're protected by various tissues that support and surround them. By definition, sensation is the arriving information from these senses. And of course, that's going to be in the form of an action potential. Perception, on the other hand, is our conscious awareness of a sensation. So that sensation has to be passed to the cerebral cortex in order for us to perceive that, at least consciously. The detection of a stimulus is really dependent on a couple factors. One is the specificity of the receptor. Each receptor has a very characteristic sensitivity, as well as the receptive field. The receptive field is the area monitored by a receptor, and receptors that have large receptive fields make it more difficult to localize that stimulus. If I advance one slide, we can see an image with two receptive fields. Here we have two free nerve endings, and they have a very characteristic field that they cover. So the larger the receptive field becomes, if this receptive field was more encompassing, it's more difficult to localize where that particular stimulus is occurring. So you can't tell if you've been pricked with a pin here or here or here because it's all covered by the same receptor. Lastly, transduction. Transduction is the conversion of an arriving stimulus into an action potential. And of course, the brain and the central nervous system as a whole, they can only interpret action potentials. So things like pain, vibration, hearing, smell, they have to be converted into action potentials in order for the brain to interpret them. And that process is called transduction again. The interpretation of that sensory information occurs when the stimulus reaches the cortex, so the cortical neurons of the cortex, and they do that via a labeled line. This concept of label line carries information about one particular modality or type of stimulus, such as touch, light, sound, what have you. And the frequency and the pattern of those action potentials contain information about the strength, the duration, and the variation of that stimulus. So for example, if a particular neuron is transmitting action potentials frequently, that's going to be interpreted differently from a neuron that is sending action potentials or propagating action potentials less frequently. And that frequency or the pattern of those action potentials dictate the strength, duration, or even variation of that stimulus. So our perception of the nature of that stimulus really depends on the path that it takes to the central nervous system. Adaptation is a reduction of sensitivity in the presence of a constant stimulus, and we can adapt both peripherally or centrally. And our nervous system is very quick to adapt to stimuli that are painless or constant. So for instance, when you put your shirt on in the morning and you feel the tag in the back of your shirt, that is a constant signal that is being sent to the brain, and the brain is going to adapt. It doesn't need to recognize the fact that you have a tag in the back of your shirt, so it adapts. And that's very frequent with constant stimuli.